So what we're going to try and do today, we're going to take a step on from what we've been doing, which is direct variation, linking variables that are directly related. And we're going to look in the inversely related, so inversely proportional to each other. Just remind me though, what have we already found out about things that are directly proportional? Can you give me any statements? Say again? What do you mean by that? Yeah, I give you the multiply, but if I add something, do I add the same as the other? So we have to be a little bit more specific. It's not quite the same as just solving an equation or something. We're saying how are they related. So yeah, if two things are directly related, if I double one, the other one is doubles. If I half one, the other one is halved, and so on. But if we add something on, that's not the same thing. Anything else that we know with directly proportional that we've figured out? What was the last lesson about? Which way round to work out k? Yes, we did discuss that, didn't we? So in your notes, we looked at, well, if p is proportional to q, for instance, we could write, you probably don't need to write this down, this is for visuals, we could write p equals kq, or we could write q equals kp, couldn't we? Both of them were correct. What was the difference? Potentially, not a have to, but potentially, yeah. If we were to use the numbers to work out this, what's k called, by the way? What's its name?
Constant of proportionality.
Good, the constant of proportionality. If we use the values for PP, it might be that if we do it one way, we get a nice exact number, and if we do it the other way, we might not. So we'd have to round. Neither of them are incorrect, but we would reduce our accuracy. Is that for you? There was something else we talked about when we visualized the relationship between these two variables. That's a big clue. We visualize the relationship. Well, we ended up with another form of visualization. When we want to display something, we often use something. Yeah. Yes. And what did we notice? Remember, we graphed it, guys?
Oh, they both go through.
When you say both, you mean if they are directly proportional, it will go to 0, 0, and it will be a straight line. So if I draw, oh, that's obviously it's wanting to. If we are to draw one like that. If I draw a different relationship that does this, what could you tell me about the constant of proportionality between the two situations there? Anything? Well, they're both proportionate, so both situations would have P equals KQ, or whatever it is, yeah? A and B, or which one? Yeah, which one? So the green one will have a higher K value than the orange one, yeah? Because it's steeper. You've seen that before, haven't you? With, remember doing the y equals mx plus c thing? Straight lines. We said we've got that, but we just have no plus c. We've just got the mx. But in this case, our m is actually a simpler. So if it was 2x or 3x, the line goes up steeper. So do you remember talking about that before? So if they are directly related, then we'll have a straight line, and it will go through 0, 0. Why does it have to go through 0, 0 again? Alistair, what's the reasoning behind it must go through 0, 0? No idea? Need to stay with me then, no? Hannah?
So then you know it's a direct proportion.
How though? What's the reasoning behind it? Why 0, 0? Why? Because remember I gave you another one that looked like a straight line, but it crossed up here. What's the reasoning behind it must go through 0, 0?
Because if you multiply and divide by the same thing, you
Yeah. So we've got that, isn't it? If P is equal to K times Q, alright? If Q is 0, then P is going to have to be 0. It doesn't matter what K is. And we also talked about like situations, like if I work for 5 hours and get $20, alright? Then I would work for 10 hours and get $40. But if I work for 0 hours, I get 0 money. You know, that makes sense. Not actually a real life situation, that, because you all know about plumbers and stuff come around your house, right? You get them round, you say, well, I've got this to do, and they'll say, right, okay, that will cost you $1,000 just for me turning up, and then we'll decide whether I want to do any work or not. And then it's every hour. So they have this, have you done in your economics or whatever, where you've got the fixed cost stuff? It's kind of like, I say do every lesson I teach, I charge $100, but I turn up, just for turning up, I charge you $500. You know, I can sit in my chair for the rest of the day, I still get my $500. So that would mean it's not a proportional relationship between my hours of working and my pay because of that fixed cost thing. It means that I don't have to spend time turning up and get no money for it. All right, so that's a bit of a recap on direct proportion. Let's look at, well, we are now going to look at inversely proportional. I think we've already discussed it. You already had a video to watch. Anyone remember what inverse proportion was about?
As one value increases, the other decreases proportionally.
Yeah. So instead of both increasing or both decreasing, if one increases, the other will decrease. Now, does that make sense to happen in real life? Eh? It does in certain situations, doesn't it? In fact, this is one of them. Let's look at this example. It takes one person 2 days to prepare 1 hectare of field. Hectare is a measure of area. And there are 16 hectares to prepare. So what we'll do is let's consider, well, what would happen if I added more people to this situation? It'd be faster, wouldn't it? I mean, we could say the more people, the more could get done. Why are we not discussing that? Because you have a farm, I have 1 field. Exactly, that's not changing, right? I've got an amount of area, but 1 field to deal with. If I've only got 1 person, it's going to take this long. If I get 2 people, I don't suddenly get double the fields, right? So this is where we are comparing which 2 variables. Okay, so we've got the time taken with, so we're going to change that. So as a variable would be number of people. Okay, so we are looking for the relationship between the time taken and the number of people. So let's create a little table. So I'm going to do, should we say P for people? Yes.
Why is it number if it says 121?
Well, that's just the first question. then says write down a function to represent the relationship between the time to prepare the field and the number of workers. So should we say, actually I've said P for people, should we say W for workers and T for time? And let's put in the information we know. We've got to do a bit of working out here, which is it takes one person 2 days. Alright? One person 2 days to prepare 1 hectare. We've been given a lot of information here. One person, 2 days, 1 hectare, but we've got 16 hectares. So, one person will take how many days for the whole
16,
thing?
32.
32 days, right? One person can do 1 hectare in 2 days. So 16 hectares will take 32 days. Yeah. Well, let's work out some more then. What do you think? 2 people? 16? Makes sense, right? We're making a lot of assumptions here. I'm sure you're aware, like, just because I double my workforce doesn't necessarily mean it's going to get done twice as quick. Yeah, they might stand around and have a chat, and, you know, one might be better than the other, but we're going theoretically here. What's the next value I can put in my table? Number of workers though. 3, 4, okay. Which one of these can I put an answer to? Go on then.
3 is
Sure.
12. Because you've multiplied it by 1.5, so that there has to divide by 1.5.
So the easiest one actually would be, well, let's double the number of workers and half the time. And the next one I would do easily is 8 and 4. Alright. I could do 16 and 2. Why is 3 a little bit more challenging for us to figure out? Because it doesn't fit in that double. Okay? We've done some nice, but Gordon said it's possible, definitely possible to work it out. Alright. Now what do you notice? If we multiply by 2, is divide by 2. Another way of saying that, by the way, what's another way of saying divide by 2? Multiply by
1.5. Multiply by half.
a half. Right, now that's quite important for the way it's going to look. You'll see this. Okay? So multiply by 2, one of them, multiply by a half the other. Okay. Now, what I want you to do, have we determined if it represents direct or inverse proportion? Well, is it direct? No, it makes no sense if I double the number of people, doubling the time taken. No. If I change the variable to how many hours of work you put in, that's different. How much area can get done in a day, that would be different. But we've definitely got an inverse relationship because when one is double, the other is half. Write down a function to represent. Now what I want to do first is I want you to go into Desmos and I want you to have a look at what shape the graph will be. Alright? And then we'll see if we can come up with a function. While you're doing it though, what do you think about the 0 thing? While you're thinking, don't need to give me an answer. Have a think. Put this into your table, put your points, see if you can come up with a function that puts a line to it. See what you can come up with. Right, ladies and gentlemen, what you've got is this shape, yeah? All right, if we go with what Gordon was saying about 3, we put a 12 in. Does that match the pattern? Does it look a little bit out? Don't know. Is it a straight line?
No.
No, it's not a straight line. We've got that. So, how would you describe it? So, if I put in 16, what was that? 2 and 32 would be 1. Okay, how would you describe that shape? Curve, yeah. All right. Now you'll notice down here I've put in an equation here. All right. So let's go back to our notes just to start with. Now, for those of you that remember, back to your books, guys. Back to your notes. Let's look at the relationship then. So what we've got is we are going to say that W is related proportionally, but not to T, so not this. Why not that? Because what would that tell me if I wrote W is related? Directly proportional, so that's not right. So what we do is this. So think about what I wrote here. What we actually have is not that, but we have W is related to 1 over T. Okay. Now that means if I double W, I actually half the size of T, which is what we want. Now what do we do with that fishy symbol?
Make them equal.
So we do W equals K. That's what this symbol gets replaced by, times 1 over T. You'll also see that written as, well, does anyone know how to do a whole number times a fraction? It just becomes K over T in this case. All right? How do we work out what the K should be? Exactly like we've done before, we use some numbers, right? So we know that when W equals 1, T equals 32. So let's use that information. I mean, I've guessed with the other ones, I've worked them out, but we're going to use this one because we were told it. So that means that if I use this, 1 equals K over 32. So what must K be? 32. Yeah. If we multiply both sides by 32 to get rid of the K divided by 32, we get 1 times 32 is 32 equals 10. So my equation then is W equals 32 over T. That's what we've ended up. How are you feeling about that? That's rapid. We've gone through that pretty quickly, but the only real difference for what we've done before is it's instead of K times T, it's K times 1 divided by T. Everything else is pretty much the same. So if we go back to Desmos, in my equation, that's what I've written. Look, what should I replace my K with? 32. So let's put 32 in there. 32, and you'll notice, look, that my curve fits my points nicely. Now, there is this other side. Because this is something we'll get to do towards the end of the year or into next year. This is actually what we call a rational function. Now, I could also change this, by the way, just in case you were wondering. What if I change this to 32 divided by x and get rid of the times 32? We get the same thing, right? So it works both ways. Why is this side of it not an issue at the moment? Why do I just not need to consider it? Negative. Why don't we have negatives in this situation? Negative people, negative time, makes no sense. So although this is there in this function, we just don't need to consider it. This is our only part. Now let me just ask you this. does, if I chuck in 3, what did Gordon say, 3 and 12, does that now work? Does that fit on my line?
Yeah. The other one that I thought was 6 and 6, I can check that.
So 3 and 12 fits, all right? Okay. So we've got here, this is important, so this is the final stage of your note taking. So we've got our equation that links, but what's also important is this shape. Now what do you notice, the 0 thing, I asked you the question, what should go in there? But does my graph show that? Because you'd basically be saying, if I had no workers, it would take no time at all. I might as well just sack everyone. Because if my field got dealt with in 0 time, if I had 0 workers, doesn't make sense, right? So this line will actually, if you try it, guys, if you were to zoom out, what happens as the line goes up and up and up? Yeah, it never actually reaches 0. It goes on to infinity. So this value, all right, oh, going the wrong way. You see, it just keeps going 0. Well, if you look at the equation, what if I put 0 into that? Do it in your calculator, guys. Do 32 divided by 0 to work out what y is. What do you get?
You can't divide 0.
Yeah, so your calculator may tell you error, but the actual correct answer mathematically is it's undefined because we can't divide. It doesn't make sense. I think Josh was saying it doesn't make sense. If you don't hire anyone, it's not that the job takes no time, the job never gets done, does it? So technically, if I'm sat there with a field waiting to be done, but no one working on it, how long will it take? Forever. Of an infinite amount of time. That's what that basically means. It's going to be infinite. All right, it will never get done.
6 is 5.3 recurring.
Now let me ask you this. This is one thing we've talked about right from the beginning of the year. Should I draw a line through the points in this question? Does it make sense in criterion D? Does it make sense? That doesn't fit, Gordon, by the way, that 312. Does it make sense to draw that line? So I've asked you before, what is a line?
Infinite number of points.
Okay, so does it make sense in this situation to have an infinite number of points?
No.
Why not?
Because you can't draw that.
There's a certain amount of.
What's the x-axis? The number of people. So what values can I have? 1, 2, 3, 4, 5. All right. So we can't have all the points in between, but what it does show us, look, is if I have hundreds of people, will it ever take no time at all?
No.
No. So this will actually go on for infinity in that direction as well, never getting to 0, because there's always a job to be done. And actually the realism here is, like I say, it'd probably be, if I have 10 people, that might be my maximum. If I have like 50 people, a lot of them will stand around doing nothing. This is no job for them to do. But in reality, that we are never going to get to 0. Just like there must be a time, the 100 meters must be at its world record and never go slower or faster, because we could never do it in 0 time. Right? So just to sum up before we pack up, inversely proportional, if you multiply one side, you divide the other. Is it a straight line? No, it's a curve. What do you get when it's at 0? Does it go through 0, 0? No, what's the value at 0? Infinite. Cool. Sorry?